Welcome to the class for the naming of organic compound. Now in this class, I'll be showing you some laws and some rules for organic nomenclature. Now what do you mean by organic nomenclature? That is the naming of the organic compounds. Don't forget, I shared some things about the organic compound in the previous class, and with this, we are going through the naming of the organic compound in this class. Now, how do we name? If you want to start with, the first law says that whenever you are given the structure of an organic compound, then the parent name of the compound should be recognized. That's the first law. So in the first law, the parent name of the organic compound should be recognized. How do you know the parent name? The law says the parent name is discovered by counting the end-to-end carbon chain. And when you now count end-to-end carbon chain, the longest carbon to carbon is the what? Is the parent name. Now when you have this, you have something like this. Now if you see, there's one end there. Let's call this carbon 1. Let's call this carbon 2. Let's call this carbon 3. Let's call this carbon 4. Now when you observe this, the carbon 1, if you check from carbon 1 to carbon 2, the numbers of carbon that is found there is just 3. And if you check from carbon 1 to carbon 3, the numbers of carbon that is found is 1, 2, 3, 4, 5, 6. So we have it to be 6. And if you have from carbon 1 to carbon 4, the numbers of carbon that is found is just 5. You count. Then from carbon 2 to carbon 3, the numbers of carbon that is found is 6. Then from carbon 2 to carbon 4, the numbers of carbon that is found is 5. And from carbon 3 to carbon 4, the numbers of carbon that is found is 4. Now if you check very well, the longest carbon to carbon chain here is from carbon 1 to carbon 3, or from carbon 2 to carbon 3. So that shows that if I want to pick the parent name for this, I can just decide to choose from carbon 1 to carbon 3 like this, or I can choose from carbon 2 here to carbon 1 to carbon 3. Now that is the parent name. And don't forget, if you can't hear, it is 1, 2, 3, 4, 5, 6. And 6 under the homologous series is what? Is X. That means don't forget that 1 is met. We have 2 to be et. We have 3 to be pro. We have 4 to be boots. We have 5 to be paint. We have 6 to be X. We have 7 to be X. We have 8 to be ox. We have 9 to be none. And we have 10 to be deck. Now, and as you have this structure, in the parent name of this, we have it to be 6. And 6 is called X. The next law, the law 2 says, now, after you have discovered the parent name of the structure like this, other carbons that are found at this will be called ligands. So that shows that there's a carbon here, there's another carbon here. And this is known as ligand. So any carbon that is not found at the parent name, that is found after you have discovered the parent name, it is called ligand, or you call it substituent. It is called ligand or substituent. That's that this is a ligand, this is another ligand. We have different ligands. Don't forget, you can have this to be CH3. This is CH3, and it is known as methyl. Don't forget, alkyl family can be called ligands. Don't forget the series. You can have the methyl, we can have ethyl, we can have propyl, we can have butyl, we can have pentyl, we can have hexyl, we can have heptyl, and so on. Now that means we have the CH3 here, we have another CH3 here. This are known as, we have this to be methyl, we have this to be methyl. That's the law 2. Law 2 says, after you have discovered the parent name, then other carbons that are found, after you have identified the parent name, they are known as ligands. Now law 3. Now, these ligands, the position, the law 3 says, the position of the ligand should be determined, or should be mentioned and should be recognized. Now, if you talked about this now, let me give you another structure. We have something like this. We have something like this. Now, this is a structure, but I'm here to open this. with the hydrogen. Now, if you have this, you can believe with me that the longest carbon to carbon chain for this will be this. Now, this is 1, 2, 3, 4, 5, and 5 is spent. Now, after we have identified the parent name according to the law 1, the law 2 says the other carbons that are found after you have identified the parent name, it is called ligand. That means we have a ligand here, and this one is methyl. And the law 3 says the position of the ligand should be determined. And let me say, the position of this will be at carbon 2. This methyl is found at carbon 2. And that is why it is 2-methyl pentane. The reason why it is pentane is because it is single bond. It is carbon to carbon single bond. We don't have double bond and we don't have the triple bond there. Now the law, under that same law 3, the case 2 says, now some of you will just ask me, why is it 2-methyl? If you should start counting from here, it will be 1, 2, 3, 4. Why is it not 4-methyl? But the law says, according to the law 3, under we have case 1, under that law 3, which says, the position, whenever you want to give the ligands a position, it should be placed in a position whereby it will be placed in the lowest possible number. Now it will assume, or it will have a lowest possible number. Now when you have, if you start your counting from here, the methyl here will be at carbon 4. So, and if you start your counting from here, it will be at carbon 2. And if you see, the one with the lowest number out of the 2, out of 4 and 2 is what? Is 2. And that's why we have to start our counting from here. That is why the methyl is having what? 2-methyl, then pentane. Then case 2, under this law 3. Now the case 2 says, whenever you have 2 ligands present in a compound, but they are of the same group. Let me give you. You have 2 ligands like this. See something like this. They are of the same groups. See this one. Now, if they are of the same group like this, the law says, look at this. If I want to identify the parent name for this, this will be the parent name. This will be the longest carbon to carbon chain. That's 1, 2, 3, 4, 5, 6. Now, after I have identified the parent name like this, then don't forget, according to law 2, it says the other carbons are called the ligands. And if you have 2 ligands like this present, and they are of the same group, you can see that this one is methyl, this one is methyl, which is CH3, and this one is also what? Methyl, which is CH3. The law says you now need to place both of them to be in the lowest possible denomination. Now, how are you going to place them in the lowest possible denomination? Now, you now assume, you firstly assume that if you should start your counting from here, you have it to be 1, 2. You can see that there's a ligand at what? Number 2. 3, 4, there's a ligand at carbon 4. So that will now be the 2 here plus 4, which is equals to 6. You firstly assume. Okay, if we should assume you start your counting from here, it will be 1, 2, 3. You can see it is, if you should start your counting from here, the first one will be at carbon 3, then 4, 5. The other one is at number 5. That's 3 plus 5, that's equals to 8. And if you check, out of 6 and 8, which one is the lowest? 6. And that is why we are going to start our counting from here. That means this we assume the carbon 1, 2, 3, 4, 5, 6. And don't forget, the parent name is 6, which is X. And don't forget, we have to bring the ligand first. And that is why the ligands are the same thing. One is found at carbon 2. So we now have it to be 2, 2. Because they are 2, we call it di. So 2, 2, dimethyl. These are the ligands that are present. And the parent name is what? X. So, but because it is a single bond, we call it hexane. That's why the name of this structure is 2,2-dimethyl hexane. That's under the case 2. Then the case 3 says that what if we have the presence of the ligands that are of not the same category. Let's say you have something like this. You have C here. You have another C here. Let me draw another structure. You have something like this. CC. You have chlorine here. You have the carbon. You have another one here. Let's say you have one here. Now, if you see this very well, let's say you have another one. Let's say you have the methyl here. You have the chlorine here. Now, see this structure now. Chlorine. Let's even say you have. Now, let me draw this structure now. Now, if you check this compound very well, the structure the longest carbon to carbon chain should be this. Now, if this is the longest carbon to carbon chain, then you observe that others are what? Are ligands. They are ligands. Now, since others are ligands, then let us list the ligands that are there. This one is ethyl. This one is chlorine, which is chloro. This one is methyl. Now, you have to follow the case 2, which says they must be placed in the lowest possible denomination. Now, let us count. You now assume that if you start your counting from here, it will be 1, 2, 3, 4. So 1 is found at carbon 4, plus we have 1 at carbon 5, plus 6. So if you check, 4 plus 5, that's 9, plus 6, that's equals to 15. But if you start your counting from here, it will be 1, 2, 3, 4. 1 is found at carbon 4, plus 5, and the other one is what? Number 6. The same thing. Now, when you have this like this, then you can start your counting from anywhere. We can start the counting from anywhere. But the case 3 says, if you have them of different category like this, then you must follow the alphabetical order ahead the numeric order. Now, that shows that if you are following the alphabetical order, then the compound that have, or let me say the compound that has the first alphabet will appear first. If you check this very well, that shows that the chlorine will appear first before others. So now, if I should place the chlorine to be in the lowest possible denomination, so that means, let me assume that this place is the carbon 1, because don't forget, it's at the middle. I have 15, 15, so I can start my counting from anywhere. So now, I'll now assume that this is the carbon 1, so that will be 1, 2, 3, 4, 5. Now that means I have 5 chloro. Now the follow alphabet is what? Is E. And that'll be 1, 2, 3, 4. That'll be 4 ethyl. Then the other one is what? Methyl. And it is found at carbon 1, 2, 3, 4, 5, 6. 6 methyl. Then the name of the structure, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. And 9, don't forget, is what? None. But because the structure is single bond, and that will be called nonane. And that is the name of the structure. Now that's the case 3. And the case 4 says, or let me say the law 4. The law 4 says, whenever you are naming organic compound, then organic compound, if you want to name organic compound, number is separated from number with the use of comma. And number is separated from alphabet with the use of hyphen. If you check this very well, we separate number from this alphabet with the use of the hyphen here. You add this as well to be the use of what? Of hyphen. You separate number from alphabet with the use of hyphen. You separate number from alphabet with the use of hyphen. You don't separate alphabet from another alphabet with any punctuation mark. But you separate number from number with the use of comma. You separate number from alphabet with the use of hyphen. But don't separate the alphabet from another alphabet. According to the comma rule, if you have something like this, see this one now. If you have something like this, you have the carbon here. You can add this as the longest bond. If you add this as the longest bond, and the parent name here is what? Is probe. Don't forget, this one is probe. And you have a methyl here, another methyl is found here. And because the methyl is found here, we can call it, they are found at the second carbon. Either you count from here or here. And that is why it is 2,2, is what? Is dimethyl. But because it is single bond, we call it what? Propane. 2,2 dimethyl propane. And as you can see, that these 2,2, because they are found on the same thing. So if you want to separate the number from number, you use what? You use comma. But you separate number from another alphabet with the use of hyphen. Then the law 5 says, whenever you want to name the organic compound, the ligands and their position will appear first. After the ligands and their position, then it will be followed by the parent name. And as you can see, the ligands and their position appear first, then followed by their parent name. Then after the parent name, the functional group or the family name will follow. And that is the structure at which we normally name the organic compound. The law 6. The law 6 says, whenever you want to name the organic compound and there is presence of the functional group, which is different from alkane family. Under the hydrocarbon, we have the alkane, which is single bond. We have alkane, which is double bond. We have alkyne, which is triple bond. So whenever there is presence of double bond or triple bond in the structure, and you want to name this, the law says this double bond here supersedes the ligand, or the triple bond supersedes the ligand. So whenever you want to name the organic compound and it's different, the structure, or let me say the functional group is different from the alkane family, then the functional group now supersedes the ligand. What am I talking about? Now, when you have something like this, you have the methyl here, you have another methyl here. Yeah. You know, on the norms, according to the previous law, if I want to name this, I have to start the counting from here because the parent's name should be this. If the parent name is this, then this serves as a ligand, this serves as another what? Another ligand. But if I want to follow the previous law, I have to start the counting from here because the ligands are here. The side at which it will favor this ligand to be at the lowest possible number is this side. Because if I start counting from here, it will be, these two ligands will be at carbon 2. That will be 2 plus 2, that is equals to 4. But if I should start the counting from here, it will be 1, 2, 3, 4. So the two ligands will be at carbon 4. That will be what? 8. And the lowest one is what? This side. But I will not start the counting from here because of the presence of the what? Of the double bond. So if I have the mixture of the double bond or the triple bond in this, I will have to start my counting to favor the functional group, which is the double bond or the triple bond. So therefore, the side at which I can name this to favor this double bond is this. So I must position the double bond or the triple bond to be in the lowest possible denomination or the possible number. And the only side at which I can use to favor this is to start my counting from this side. So now, the naming will now becomes, don't forget the law I explained now, the ligands will come first, and the ligands we have here is methyl. And so if I'm starting the counting from here, this methyl will be at carbon 1, 2, 3, 4. So they are at carbon 4, and that will be 4, don't forget, comma 4. And because they are 2, so we have it to be what? 4, 4 dimethyl. But the parent name is 1, 2, 3, 4, 5. And 5 is what? Pent. And the position of the alkene functional group should also be mentioned. And that's why we have it to be pent 1 in. But because it is pent 1 in, we can just call it pentene. But if it is positioned like this, let me say you have something like this. See, if you have something like this, then this one, don't forget that the pentene is found at the second carbon. No, sorry, the alkene functional group is found at the second carbon. So if I want to name this, you have it to be 1, 2, 3, 4. And 4 is what? Boots. So I will have it to be what? Boots 2 in. Boots 2 in. Now, the law 7 says, now, what if there is presence of the ligand, the presence of the functional group, that is, the hydrocarbon, and the presence of the other functional group? Let me say, the law says whenever there is mixture of the functional group of organic 2 and the functional group of organic 1, then the functional group of organic 1 of the organic 2 supersede the one of organic 1. The functional group of organic 2 supersede the functional group of organic 1. Let's say, for instance, if you are talking of organic 2 functional group, you have the functional group of arachidonic acid, you have the functional group of arcana, you have the functional group of arcanon, you have the functional group of aqua, that is arcanon, you have the functional group of arcanoids, that is ester, so etc. This are organic 2. And the organic 1 will have the functional group of organic 1 to be hydrocarbons. And if we are talking about the hydrocarbons, they are alkane, that is ANE, we have alkane, that's double bond, and we have ine, which is YNE. So this organic 2. Now the law says whenever there is presence of these two, then the organic 2 supersede organic 1. That shows that you must position the organic 2 to be in the lowest possible number. You know, when we have the mixture of the ligands alone, when we have the ligand alone, the ligands control the way of counting. You place the ligands to be in the lowest possible number. But when we have the mixture of the ligands and the organic 1 here, that is double bond or triple bond, then the organic 1 supersedes the ligand. Then you must place the ligand to be in the lowest possible number of counting. Then when we have the mixture of the ligands with the organic 1 and organic 2, then the organic 2 supersedes the organic 1. Then you must place the organic 2 to be in the lowest possible number of counting. Let's say, for instance, you have something like this. Now, when you have something like this, don't forget, you have a ligand here. Let's say you have a ligand here, you have a ligand here. You have a functional group here, you have a ligand here. Now, if you want to name this, you will observe that the only side to favor these ligands to be in the lowest possible number of counting is to start my counting from here. But I will not start my counting from here because of this organic 2 that is here, which is arachidonic acid. Then, if I want to name, don't forget there's a functional group of organic 1 here. So I will not observe this, I will have to observe the organic 2. So in order to place this organic 2 to be in the lowest possible number of counting, then I must start my counting from here. So that shows that this carbon assumes the carbon 1. So now, That shows that if this is carbon 1, this 2, this 3, this 4, this is 5, and this is 5. We have 1, 2, 3, 4, 5, and 6 rather. Now, if I want to start the counting, that means the parent name is 6. We have this to be the parent name, and that's 6, and 6 is what? X. That's the parent name, according to the law 1. And according to the law 2, other carbon or other attachment that are not part of the parent name are called ligand. So this is a ligand, it is methyl. This is another ligand, it is chloro. Then the law says, if you want to name this, they must follow the alphabetical order. That means the first alphabet will come first, and we say we have carbon 1, 2, 3, 4, 5, and 6. Then the chlorine will come first because of the first alphabet that it is. We have it to be at carbon 4, so that's why we have it to be 4 chloro, and the other ligands, which is at carbon 5, we have it to be 5 methyl. Then the functional group is what? Is X. The parent name is X. And don't forget the position of the organic 1 as well should be mentioned. And the position of the organic 1 here, don't forget, is at carbon 4, which is 1, 2, 3, 4. So the position of the organic 1 here is at number 4. So we now have it to be X4. But there's a mixture of organic 1 which is in, and the mixture with what? With arachidonic acid, which is anoic acid. So we have the mixture of organic 1 and organic 2. The law still says that the organic 2 must be the one to end the naming, and that is anoic acid. But we cannot just erase the organic 1 like that. If you just put X4 anoic acid, then as a scientist, you may not be able to observe that there's a presence of organic 1 in the structure. But the presence of organic 1 as well must also shown in the question or in the naming. So therefore, we now have the structure like this. So we check that I cancel this where we have the same thing, which is N. So I will turn these two N into 1. So therefore, I will now name it like this. So I have the structure, I cancel this where we have the same N, then I name it like this. So let us now take the naming from here. It will now be enoic acid. And that is why the structure is 4 chloro, 5 methyl, then we add this to be what? 6, which is X4 enoic acid. So this is the law 7. And the law 8 says the organic structure can also be in a zigzag manner. Now, whenever you are talking about the zigzag, you have something like this. Now, if you want to name something like this, then you have to follow the natural naming of the straight chain as well. Then if you want to name this, you have to observe that the end and the corner of this zigzag represents what? Carbon. So if I want to name this as well, I will have to start it to be 1, 2, 3, 4, 5, 6, 7. And 7 is ept. And this is single bond, so we'll call this what? Ethane. So this is ethane. But what if you have something like this? If you have something like this, then if you observe this very well, we have this to be, let's even put something like this. This one is 1, 2, 3, 4, 5, 6, 7, 8. But there's a presence of double bond here. So, and it is found at carbon 1 because you have to place in the lowest possible number. And 8 is what? Oct. And don't forget that it will now be what? Octane, because of the presence of the word of the double bond. And I believe with all this law, you should be able to give the word name for the words, for the organic compound. Thank you very much. Let us have your comment, like, and subscribe. God bless you.